This is Dr. Holt. This is a continuation of a previous video. On our previous video we found that the position, or x position, was located at 422.5 at t equals 12. What I'm going to do here is I'm going to use the kinematic equations and I'll write them down, that x is going to equal to x initial plus vi times t plus 1/2 a times t squared. We're going to use that equation, and we're going to use that v position is equal to vi plus a plus t. So we're going to use these two equations, and we're going to try to find out by using these that we can find out the same position. Alright, so we'll start out. Come back to our initial velocity. Our initial velocity was -10. So we'll find out what our position is. So we're going to do this in time increments. We're going to go between this time increment, which is 0 over to 3. So I'll do 1, 2, 3. So I'll say the x position between 0, 3 is going to equal to my initial position, xi, and initial position is given as -40. Plus my initial velocity, and again my initial velocity was given as -10. So I'll change this to -10. -10 times my time interval. My time interval is going to be 3. And let's see what our acceleration was. We go to our acceleration graph. Acceleration was 20 right here. So we go plus 1/2 times 20 times 3 squared. So when we do those numbers, that gives me -40 minus 30. That's 1/2, that's 10, that's plus 90. Add those two together, and that gives me a position of 20 meters. Now we'll go another increment between 3. We go back to our graph, and we're going to go for 2 more seconds right here. 3 to 5. That's going to equal to my position that we had previously, which will be 20. Now we're going to find out what is our velocity after 3 seconds. Well, since we've drawn our graph, we know we're at 1, 2, 3. We're going to be at 50. So we go plus 50. Again, we're going to do it over 2 seconds. Plus 1/2. We go up to our acceleration time graph, and we look, and we're going at 10 in this increment. So that would be plus 10 times 2 squared. We run those numbers, we get 20 plus 100. That's going to be 5 times 4, that's plus 20. That gives me a position of 140 meters. Again, we're just kind of slowly working through that. We'll see if we get the right numbers. There's 20 and then 40. Alright, so we go back to our graph. We've gone over to here. So now we want to go over 1, 2, 3 more seconds. So we're going to go between 5 and 8 seconds. We take our position, which is going to be 140, plus we go find out what our velocity is going to be as when we start that. So we go 1, 2, 3, 4, 5. At 5 seconds, my velocity is going to be 70. Again, we look and see what time increment we're going from. We're going to 1, 2, 3 more seconds. So we do that times 3. Plus 1/2. We look at and see what our acceleration is going to be at that point in time. So at that point in time, we have dropped all the way down to -15. Over 3 squared. Alright, so now we'll run that number. That gives me 140 plus 210. And I need the calculator on that. That's 0.5 times negative 15 times 9. That gives me minus 67.5. We'll add that 140 plus 210 minus 67.5. That gives us 282.5. Okay. And we come back. We are over 8. Now we need to do another 4 seconds from 8 to 12. So x position between 8, comma 12. I don't want to do a comma. I want to do dash. 8 dash 12. We take this position that we had, 282.5 plus the velocity that we are during that point in time. We are going to be at 25. So we put 25. We're going to be operating over 4 seconds. Now we've got to see what our acceleration is going to be during that time increment. Our acceleration here is going to be 5. So we do plus 1/2 times 5 times 4 squared. And we will see what we be. 282.5 plus 25 times 4, that's 100. And then plus 0.5 times 5 times 16. That gives us 422.5 meters. That's where we should. We'll check and see what we got earlier. And we got 422.5. So as you can tell, the kinematic equation work extremely well. Again, all they're doing is you're just getting the area under the curve. So I hope this video helps you. It's comparing using the kinematic equations with the answers that we got on the previous video where we did the area under the curve at t equals 12. So both of them working. Let me write that as t is equal to 12. Alright, best of luck with this. I hope this helped you guys.